Hello everyone, and thank you for watching this recording. My name is Katharina Papst, and I will be presenting multimodal communication in the digital age, a cross-linguistic investigation of language variation in video conferencing, on behalf of myself and my co-authors Johanna Aminoff, Aida Alanzi, Raisa Tayyip, and Derek Dennis. With the advent of the COVID-19 pandemic, video conferencing has become an indispensable part of life. This has led to the development of a unique multimodal linguistic register, which combines features from in-person interaction with written features from chat messages and reaction buttons that allow users to show approval or indicate their intention to speak. Video conferencing's sudden rise in popularity opens up many linguistically relevant questions. For example, how does this emergent multimodal register compare to in-person conversation? How do the rapidly developing interactional norms of this register differ across languages and varieties? And finally, what role do speakers' demographics play? Our project addresses these questions through a variationist lens by drawing on two types of comparisons, as seen on this slide. A comparison by medium, in which we examine the same speakers during in-person and online conversations, and a cross-linguistic comparison, in which we investigate similarities and differences in the video conferencing register across languages and varieties. Data collection is ongoing. From the United States, we have in-person and online conversations with the same speakers, with the in-person data being collected prior to the pandemic. We also have comparable collections of video conferencing conversations from 5 other countries. All of these conversations were collected on Zoom during earlier stages of the pandemic, when only online data collection was possible. Our intention is to eventually collect in-person interviews in these countries as well. Several varieties that we're targeting, such as Ghanaian English, Asante Twi, Finland Swedish, and Gulf Arabic, have received comparatively little attention in variationist work, making this project an important step towards more inclusion of lesser studied languages and varieties in the field. Now, collecting data in 6 different countries requires a team that is globally situated. We are lucky that our research team consists of individuals born and raised in 5 different countries. Each of us is collecting data in one country, usually the one we were born and raised in. I'm the only one who is collecting data from 2 places, namely from Germany, my home country, and the United States, where I also collected the data for my dissertation. All 6 of the countries that we're currently collecting data in are highlighted in dark blue here. Please note that the data only comes from one community or region per country, meaning it is in no way representative of national varieties. But given how small some of these communities that we've gathered data from are and how far they are from each other, we simply felt that this was the most accessible way for us to visualize where we are collecting our data. Today, we will be looking at data from 5 conversations, 1 from each country. Please note that the Canadian data is not included here because it is still getting transcribed. Each conversation has 3 participants, and these participants represent a variety of genders, ages, and ethnicities. Most of them are highly educated. We also collected data on how comfortable participants feel with Zoom and other video conferencing platforms, as well as how relaxed and comfortable interviewers felt during the interaction, to investigate if these factors influence participants' linguistic patterns. Given that we are still in the initial stages of data collection, we will not be discussing the influence of these factors today, but we would like to note that this is something that is very much on our radar and will be explored in more detail as we expand the corpus. Our goal is to investigate 2 phenomena that we expect to vary between in-person and online interactions. The first of these is the use of interlocutor responses, also known as back-channeling, and that is the use of minimal responses like and aha to signal engagement and keep the conversation going. The second feature is turn-taking, and that's the strategies individuals use to select who gets to speak when. Differences in the use of these features can easily lead to misunderstandings. For example, someone who backchannels a lot or uses speaker selection strategies that their interlocutor is not familiar with could easily be perceived as disruptive or rude. Both interlocutor responses and turn-taking are inherently interactional phenomena, which have been notoriously difficult to quantify for comparison. So one of the major challenges for this project is developing an accountable methodology for quantifying these phenomena. In the following, I will present how we've been going about this for interlocutor responses. Following ISVIA 2020, we define interlocutor responses as all those things interlocutors do during a speaker's turn that do not lead to the interlocutor taking over the floor and becoming the next speaker. I will illustrate this for you with an example from my German data, which involves me telling two friends about my recent attempts to start running. You can see a transcript of the German original on the left and an English translation on the right. Note that in line 7, Viola, the speaker at the bottom of the screenshot, responds to what I say. However, I do not yield the floor. In other words, interactionally, Viola's contribution is treated as an interlocutor response rather than a turn. In line 9, she does take over the floor. In fact, I directly respond to what she says in line 10. This means that interactionally, this contribution is treated as a turn. Using ISVIT's framework, we coded all of our data into turns and interlocutor responses. To reliably quantify the frequency of interlocutor responses, we're counting the number of responses reacting to a turn divided by the number of words in said turn. Let's take a look at some preliminary findings. For investigating interlocutor responses, the first step is determining the length of each turn. This graph shows the distribution of number of words in turn by setting, with the number of words on the x-axis and the density on the y-axis. Note that I'm deliberately talking about setting here rather than country or language because many of the conversations we recorded involved multiple languages and varieties. The term setting is supposed to denote that the data was collected in a situation where the variety in question would be expected to be the most dominant one. Previous work on in-person interactions has shown that the mean length of a turn in spoken English conversation is around 100 words. When we compare our video conferencing data to this, we immediately note that turns in video conferencing interactions tend to be much shorter. There is some variation between settings, but recall that this graph is based on one conversation only, meaning we shouldn't put too much weight on this. However, the fact that all 5 conversations tend to have much shorter turns than in-person interactions suggests that turn length is an important difference between in-person and online conversations. Next, let's take a look at the number of interlocutor responses, here on the y-axis, by the number of words in turn, here on the x-axis. We see that for each setting, the number of interlocutor responses increases with turn length. This is in line with ISVIT's findings for in-person interactions and intuitively makes sense. The longer someone speaks, the more we indicate that we are still listening. This slide shows the number of interlocutor responses per 100 words, a normalization technique recommended by ISVIT. The red dots indicate the mean number of responses, the thick black lines indicate the median number of responses, and the green line indicates the mean number of interlocutor responses in ISVIT's in-person conversations. One thing that immediately stands out is that the median is 0 for all 5 settings, and that the mean number of interlocutor responses tends to be higher in in-person conversations. Given that turns in video conferencing tend to be relatively short, and short turns get fewer responses, that's not surprising. An ANOVA analysis shows that there's no significant difference between the 5 settings. However, recall that our data is based on one conversation by setting only, meaning this may change as we expand our data set. While we're fairly confident in our operationalization of interlocutor responses, we would love your feedback on our approach. Another challenge we would like to get feedback on is how to code for interlocutor responses that include nonverbal feedback such as laughter and nodding. So far, we've only coded for verbal responses, such as those circled in green here. Note that we are also counting reaction buttons, but these are very rare, with only one instance attested in the data so far. What is more common is that speakers don't explicitly say anything but respond with a smile or laughter, as interviewee 2 here in the response circled in gray. The participant's laughter is clearly a reaction to something, but how do we know it's a response to interviewee 1's turn and not in solidarity with the interviewer's laughter, or in response to something that is happening off screen? We'd love to get your input on how to treat embodied interlocutor responses like this one and code reliably. Finally, another challenge we have is how to normalize the number of responses per turn. Following IceVIR 2020, we normalized our data here by looking at the number of interlocutor responses per 100 words, which is the average turn length in IceVIR's in-person interactions. But our average turn length is different. Moreover, the languages and varieties we are looking at are morphologically different, as illustrated using a few of the varieties we target on this slide. So turn length in words may not be a meaningful comparison. We'd love to hear your ideas for how to account for this. Based on the challenges we have introduced today, we have 3 questions for you that we would love to get your feedback on. First, do you have any thoughts on our approach for quantifying and comparing interlocutor responses? Second, do you have any recommendations for reliably and accountably coding nonverbal interlocutor responses such as laughter and nodding? And finally, do you have suggestions for how to normalize the number of interlocutor responses cross-linguistically? We gratefully acknowledge that this work has been funded by generous support from the UTM Office of the Vice Principal Research. These are our references. Thank you. Please get in touch if you have questions, comments, or suggestions. You can email me using the address on this slide or contact me on Twitter. I will be happy to share your message with the rest of the team.